Okay, 1.33, it says, assuming the red gear on the right is the driver, what would be the output torque if the input torque there was 15 Newton meters? Well, the gear ratio would be 4/2. 4/2, so the gear ratio is 2. And if we're going to put in 15 Newton meters, we take that times 2, we should get an output of 30 Newton meters. That was easy. Okay, next problem. It says calculate the gear ratio of A to B. A is the input, B is the output. That would be 12/20. If you want to do that in decimal form, it'd be 0.6. It says what is B to C? So that'd be 5/12. If you did that, it'd be 0.417. If you did C to D, it'd be 20/5. That gear ratio is 4. And then it says, what's the gear ratio of A all the way over to D? And the way you can do that is you can multiply all the gear ratios in between. So you do 12/20 times 5/12 times 20/5. And you'll notice the 20s cancel, the 5s cancel, and the 12s cancel. So your gear ratio is 1/1, which means you can skip the gears in between. You can just do A to D, which would be 20/20. So see, it was 1/1. So these gears in between are just idler gears. They just change the direction of the rotation. That's all that are really used for, to maybe space out 2 gears or something. You can go from A directly to D. Okay, next page. It says 1.38. This is question 1.38. It says calculate the overall gear ratio of this compound gear. So gear D is the driver is gear A, I guess, here on the right side. Gear A is 10 teeth, and it's turning a 40-tooth gear B, so that gear ratio would be 4. And then times gear C is a 20-tooth, and it's turning a 50-tooth, so 50 divided by 20 would be 2.5. Multiply those gear ratios together, and we get a gear ratio of 10. Gear ratio of 10. This is a compound gear. A is turning B, and C is turning D, but C and B are on the same axle, so it's like a wheel and axle with B and C. Okay, next one. It says, assuming that pulley A, that's this one here, is the power source or input, and that it moves clockwise, which way would the other pulleys rotate? Clockwise or counterclockwise? Okay, so if this one is going clockwise, that means this one's going to go this way. That's counterclockwise. So that's a counterclockwise. That means this is going this way. That's clockwise. And this would go also this way. That's clockwise. So that would be your answers for 139. 140 says, what are the following gear ratios from the above drawing? A to B. A to B would be 3/6. That'd be a 0.5. A to C, that'd be a 10/6. That'd be a 1.7. And then A to D, that would be a 8/6. That would be a 1.3. That'd be 1.40. 1.41 says if the torque force provided at pulley A in the above drawing is 120 pound-feet, so 120 pound-feet, that's the input torque. What are the corresponding torque values at B, C, and D? So all you have to do is take 120 times 0.5, 120 times 1.7, and 120 times 1.3 to get your output torques at each pulley. So it'd be 60, it'd be 204, and it'd be 156 if you want to check your work on that. Okay, on this one it says, what is the gear ratio from the first gear to the third gear? So if we just measure the teeth, the first gear, we'll assume it's one on the left here, that has 8 teeth. And then this one here has, let's see, n equals 16, has 16 teeth. So the gear ratio is 16 over 8. That'd be a gear ratio of 2. That's number 1.42. 1.43 says, if the first gear rotates at 60 RPM, how fast is the third gear rotating? Okay, so that would be half as much. So it'd be 60 RPM divided by the gear ratio. So that'd be 30 RPM. Notice this third gear over here is bigger, so it's going to be going slower. And then 1.44 says, if the output of torque gear at 3 is 150 feet-pound, what is the input torque gear at 1? So again, I'd have to take 150 divided by 2. And I should get an input gear of 75 feet-pounds, or pound-feet, because the gear ratio is 2, so 75 times 2 would give me an output torque of 150. Okay. Next problem. Assume we will mesh a gear D with gear C in the above compound gear system. Power is supplied at gear A. Gear A down here with 100 feet-pound, 100 foot-pound going in there. And it's also spinning at 1600 RPMs. So there's an input speed and an input torque for A. The necessary torque output for the system is 500 feet-pound. So we need to get 500 feet-pound of this entire gear system at gear D, which of course isn't on there yet. I could go ahead and put there's a gear D that's going to be attached, meshed with gear C. This is gear D. So the output torque I need to have is 500 feet-pound total. Feet-pound. And I got 100 feet-pound going in gear A. So what's the overall gear ratio need to be? It would have to be 500 over 100. Overall gear ratio needs to be 5. Okay, so that's 1.45. The answer to 1.45. 1.46 says, with the system torque output of 500 feet-pound, how many teeth should gear D have? How many teeth should be on this gear D? So if you go look at gear A has, 10 teeth. And gear B has, if you count up all the teeth there, it's 20. So 10 to 20, that's a gear ratio of 2. Times, and then C has 16 teeth. How many teeth does D have? So the gear ratio there would be N over 16. And 2 times that gear ratio should give me an overall gear ratio of 5. So that means N over 16 is going to equal 5 divided by 2 would be 2.5. So N should equal 16 times 2.5. And so N should be 40 teeth. So gear D should have 40 teeth. Okay. Good. Okay, this question. Pulley A is on an axle and is moving at 1500 RPM and has a diameter of 15 inches. So there's going to be an axle here and there's a pulley on it, pulley A. And it's going at 1500 RPMs. Diameter is 15 inches. Okay. 3 pulleys, B, C, and D are on these. B, C, and D are on these, and they're all different sizes. Are attached to a single axle pulley to the first one. So a belt is around pulley A and can be connected to any of the other 3 pulleys. Okay, so I have a pulley like around from here to here, but at any moment the belt could be shifted over to there, or it could be shifted over to there. Okay, depending on what you need. Okay, given a moment to change the speed and torque output within the system. Okay, so 147 says an output speed at pulley B is 1750. So what's the diameter of it is what we're trying to find. So that's what we're going to do in all 3 of these problems. Pulley C is going to be 2000. Pulley D is going to be 3250. So you'll notice that they're all spinning faster than what the input speed is of A, which means all three of these need to be smaller pulleys than that one. So the way we can do that is we can take the output speed, right, over the input speed should equal the input diameter over the output diameter. Remember, it's an inverse relationship with the angular velocities. So I could do that for every one of them. I could do 1750 over 1500 would equal 15 over the B diameter of B. And I could just switch that out all the time and put the new angular velocity in. So if you do that, B, the diameter of B, I think is 12.9 inches. This one is 11.25 inches. And D, I believe, is 6.9 inches. See, D is the smallest pulley because that's why it's going the fastest. So hopefully that makes sense. Okay, last two problems. 1.50, we have a 22 tooth sprocket connected to a 48 tooth sprocket. So the gear ratio would be 48 over 22. That's like about 2.2. So the angular velocity of the 22 tooth sprocket's 4. So and the input torque is 54 Newton meters. Okay. So question 150 says, what is the torque transmitted to the 48 tooth? So we're gonna up the torque. So we're gonna take 2.2 times 4, or nope, 2.2 times 54. Sorry, and that would be like 118 Newton meters. So we're gonna up the torque. What are we gonna do the speed? What's the output speed? Well, we're gonna take 4 divided by 2.2, and we should get like 1.83 RPMs for the output torque. This is a bigger wheel. It's going to spin slower than this smaller wheel. The smaller wheel is spinning at 4 RPMs. So this one's going to spin at 1.83 RPMs. And that's all your check mark problems for your gear ratios, your gear problems in the book. So hopefully you can go do the E-Lab and maybe we can get ready to take this test.